Good morning, guys. It's Naveen joining the call. Can you guys hear me? Rahul, Moin, Shrishel, can you hear me? Great. Thank you, guys. So I think I was just waiting for others to join in. Maybe we can get started for today. So we couldn't join yesterday. Came back from my village, hometown, and I got a little late and I couldn't get back onto the call, guys. So sorry about that. So today I want to give a brief introduction of Kubernetes, and we'll go dig deep into it. And we'll also try to touch a little bit of CI/CD after this one, and we'll go into that one if time permits today, guys. Okay. So that is going to be the plan. And before we get into the Kubernetes and things like that, Rahul, would you have any idea? I've been creating a few instances, and it looks like somebody had been stopping them. Today morning I terminated them, but it looks like some of them have been stopped. I don't know if there is any script or anybody terminating them or stopping them. Would you have any idea?
I don't have any idea, sir, but maybe.
Yesterday,
don't know, sir.
I created a few of them and I couldn't find them also. So I was just checking in, seeing like that. I was just checking, but that's okay. Nothing to worry. I was just curious to find and things like that. Okay. If you don't have any idea, that's fine. We'll see and continue. So today we'll start with a little bit of Kubernetes and we'll try to understand a few aspects of it. And we've talked about Docker's containers. So this is an extension of the Dockers in the container world. The official definition of Kubernetes, it is open source, which means it is free. Container orchestration tool. In real world, when you get into the business environments and enterprise environments, we end up creating not just 1 or 2 or maybe 3 or 4 or maybe 10 containers, but we may end up in situations where there are hundreds and hundreds of containers are floating around, hundreds and hundreds of instances of containers are floating around, and managing each one of them manually becomes very, very time consuming and very unproductive. That is where the orchestration tool, container orchestration tool, comes to rescue, and we'll try to understand how it helps and things like that. It was originally developed by Google. Google is the godfather of the Kubernetes, one of the most popular things, applications going around now. It helps manage containerized applications. So in other words, Docker creates the containers, and the Kubernetes can be thought of as something which is used for management of the containers in different deployment environments, which is, it could be a virtual machine, a single node, or a multi-node cluster. We can use Kubernetes is what it means, guys. Okay, moving a little ahead. So what problems does Kubernetes solve, and what are the tasks of the of an orchestration tool? That's what we'll try to understand. So need for a container orchestration tool is traditionally there were monolithic architectures. So in other words, monolithic architectures is where all the components of an application are plugged into a single server and everything works on a single server. And if there are any problems, it becomes difficult for us to understand what is the problem. It becomes very time consuming and unproductive. So all multiple services are put together as different components, and that is what is monolithic. It could be in a single server or maybe a single entity, and that is really what is monolithic architecture, guys. Okay, then we have come across the microservices, which is the latest and the greatest. Here, this is coming into existence because of multiple containers which are working. And these containers are not just 1, 2, or 10s, but they could be hundreds of containers in a business or an enterprise world, because we have many servers we work with in an enterprise world. So demand for a proper way of managing those hundreds of containers is what is the output of the Kubernetes. Kubernetes came out because there was a reason, there was a requirement of managing these hundreds of containers without having to go and deal with them manually. is what it is really about, guys. Okay. So what features do orchestration tools offer to offer high availability or no downtime? We have an application running on a single server or multiple servers and things like that. If the application goes down, or maybe if a process goes down, if a server goes down, or maybe if some of the components of it goes down, or maybe some of the network settings or the IP addresses change, then what do we do? The current application may become unavailable. What do we do? Well, that is what is downtime. So if any of these things go down, we need something to be automatically taking care of that. What is that? That is high availability. In other words, we want to reduce the downtime, or maybe more preferably have no downtime at all. Scaling up or high performance this is more about an elasticity, especially in the world of cloud computing and things like that. We have imagine we have a small app, and let's say a lot of users are coming to access the app, and maybe on festivals the demand for the app grows very, very high, or generally during festivals the demand grows exponentially high. So suddenly, if we were to manually install the servers, softwares, licenses and things like that, it would become very, very difficult for us to manage that kind of aspects. And that is where we need to increase the demand, increase the number of services based on the demand. And what is that? That is load. That is what is high load or scale up. You can increase a single service capacity, which is referred as scaling up. Scaling out is where you're adding more number of servers to deal with the requests. Both of them can be used to solve the same problem. That is what is high scaling. So in other words, as the demand increases, as the demand increases, we want to increase number of servers. And as the demand goes down, we want to automatically bring down the amount of servers and how much we are using and our costs and so on. So that is what is scalability, guys. Okay. Moving a little ahead, this is disaster recovery. For some reason, if a server goes down completely due to some reason, maybe it's a commodity server, maybe an enterprise class server, and something went off and things like that, we would still like to be able to handle that one. What is it? That is where the orchestration tool. So ideally on the server, whatever the hosts or the containers are running, they will go down. Now imagine a way if there's another, if there's a tool which will automatically bring up these containers on another server and make sure the requests are served, because these are maybe very, very important transactions which are happening on an application and things like that. That is what is disaster recovery. Or again, it could be maybe a physical disaster also could be referred to a disaster recovery, guys. Okay, in such case also, Kubernetes comes to our rescue. So in Kubernetes, from an architectural standpoint, generally we keep referring to nodes. Nodes could be virtual machines or the physical machines themselves. Then we have the control plane. Control plane is referred as a master, and we'll try to talk a little bit about that. It is based on a master worker architecture. The master is referred as a control plane. There are a lot of workers. Workers is where the actual work is going on. That is why they're called as the worker nodes. We can think of a IT company like a project manager and all the software developers, or maybe the network engineers. All the network engineers are the workers. The master is like the project manager who's managing. The master only manages it. They don't actually do the actual work, is what you can also relate it to. So these are also referred as the nodes, as simple as that. Then we have a kubelet. Kubelet is referred as an agent or a node agent. It's nothing but a lightweight process which runs on all the workers, and it keeps sending the requests and other kinds of, it accepts requests also from the master and tries to serve them, is what it does. That is what is agent. So in other words, we have to manually run this agent on all the nodes, is what it really is, guys. Okay. Worker nodes also have the actual containers running in Docker hosts and things like that. So that's where the containers are actually doing their work. The apps are sitting inside the containers and they are performing whatever is being requested. And more importantly, they are independent of each other. So if the containers fail, the others are not impacted. If something did not come, a file did not move into a single container, other containers are not impacted by it. They all work in an independent way, and they are working the worker nodes, guys. Okay. Master is the control plane. This is where all the master processes are run. K8 refers to Kubernetes. I think if you take KUBE, that's about 4. RNET, that's about 8, 10. 10 letters are there in Kubernetes. I think somehow they came up with that 8S, K8S as an abbreviation. Something like I I thought it was something like 8 letters in that one, and but again, that is just to give you an idea, guys. Okay, so what are these components or processes inside the master that are running in Kubernetes or the control plane? Is the API server. API server is the entry point. So whether we use a UI or an API server or a CLI, UI is you're actually accessing the Kubernetes UI, which is most of the time we may not directly use UI. UI is slightly less powerful. All the requests are being routed to the API. API is where all the rest, the URL based requests are being routed, and the API server takes all these requests and goes ahead and processes them internally and sends the response back. CLI is the command line interface. That is generally most of the time what we use. Controller command line interface, as simple as that. That is the most powerful tool. All the Kubernetes commands and things like that are generally executed from here. There are tens and tens of them. We will look at some of the important ones and so on. Controller manager keeps track of what's happening in the cluster. So the master constantly keeps track of all the workers and tries to understand who is up, who's down, who's busy, who's not busy, and things like that. All these kind of things are being managed by the controller. So that is why it is referred as a controller manager. What's happening in the cluster can be thought of as, guys. Okay. Then we have the scheduler. Scheduler ensures pod placement. We'll try to understand what is a pod in a bit or a minute. Scheduler decides where new pod should be scheduled, or in other words, it is tracking who is doing how much amount of work, which server is completely occupied versus which one is free. So when a next container or a pod needs to be brought up, it will kind of balance the work, balance the load between the servers, so that some of the servers are not overutilized and some of the servers are not underutilized. A balance of all the servers is at place and things like that. That is what the scheduler is tracking. It routes the loads to the servers which are either overutilized or underutilized, and it makes a decision, guys. Okay, so the next one is etcd. Etcd is a Kubernetes backing store. In other words, more precisely, the metadata of the control plane or the master is generally stored here. That is generally used by the master for understanding the different aspects of all the above three things we discussed: who is working, who is engaged, who's not engaged, who's overutilized, who's underutilized, who's alive, who's dead, and things like that. And any other configurational stuff also, which is related to the workers, or also can be stored into the etcd. It is a database internal to the Kubernetes is what we can think of, guys. Okay. Rahul and Shishil doing okay so far? Can you give me a quick yes, please? Okay. Then the virtual network is we can have 10, maybe 100, or maybe 1,000 nodes inside a cluster, and together all these cluster of nodes will act like one single computer. That is what the virtual network is responsible for taking care of. So in other words, internally the virtual network allows the communication between all the masters and the workers and makes it look like it is only one computer at work, irrespective of how many computers are there. That is what can be thought of as the virtual network, guys. Okay. So the control plane nodes are generally a handful. Handful means a couple of them. They're very important. Generally, most of the time, they're enterprise class servers, heavy servers, expensive servers, and things like that, because all the important information, or more precisely, the metadata of all the workers is generally taken care. So at any point of time, if one of the master goes down, then we can have another master act as a primary backup or hot backup, and it can start serving the requests. And workers are generally the ones who are doing the heavy work, the actual work, and bigger and more resources. They also, there's a combination of whether they're commodity and enterprise class servers. Sometimes they're bigger, sometimes they're also smaller. But they are the ones who are performing the actual work of an application. And master is where all the metadata is being maintained. So if one of the master goes down, the second one acts as a hot or a primary backup and tries to serve the request for the master. Then some of the components, these are some of the important components of Kubernetes we'll try to understand. So start with node. Node is nothing but it could be a virtual machine or a physical machine. Then moving on to the pod. Pod is the smallest unit in Kubernetes, and it's an abstraction or a container, which means really it is nothing but a container with a layer added on top of it, and it is referred as a pod. You can, for the sake of simplicity, you can kind of think of pod as a part of a deployment or a piece of a deployment, is what it is. So that is what is pod. It's nothing but container plus a single layer. The single layer is a Kubernetes layer. So the container will be read-only. The Kubernetes, whatever modifications or whatever it needs to do, whatever interactions it needs to do, it will just do with the layer and take care of managing the container is what is really happening. So that is what is pod will be using it heavily, is what it is. Usually one application per pod. In other words, in a container, we can use one application. You can also use multiple applications. That really depends on the application architecture. We don't make those decisions. A technical architect or an application architect will make those decisions. But most of the times, as part of best practice, we will deploy one application into one container, which means like an entire web application is there inside one container. Its related database may be plugged into another container, but both of them can also be plugged into a single container. But generally, that is not a good practice. So because if we run into any issues and things like that, it will take a long time, and there could be other problems from an application architecture perspective, which may not be a really good idea. And it also depends on application to application, guys. There is no hard and fast rule. But again, that is not our generally our worry. That is generally left to the application architect or the technical architect for the most of the time. Each pod gets its own. See what we have here. Gets its own IP address. In other words, the pods get their own IP address. There is also one problem. The problem is pods are ephemeral. Ephemeral means they're temporary. In other words, they may go down. And if a pod gets an IP address and it goes down, what can happen, guys? The Kubernetes tool is constantly watching. It will try to bring up another pod on another node, or maybe in this same node, it will try to start another pod. But what could be the problem? In such case, the IP address may change. The IP address will change, and the pod may get a new IP address. In such a case, all the previous applications which are pointing to the old IP address need to be changed, which could be a problem. Okay, so new IP address on recreation is a problem with the pod. That's where the service comes to your rescue. Service is kind of a wrapper around the pod, and it generally can be allocated a permanent IP address. So within it, a service can have one pod, or maybe it can maintain multiple pods. And the pods, even if their IP addresses change, the IP address of the service will not change. So all the other applications, when a pod goes down, the service will take care of it. It will bring up the pod on the same node, or it can also bring up the pod on the other node. And since its IP address will not change, all the references of the previous or the old applications do not have to be changed, which is a lifesaver for all the other applications, so especially when you have a lot of dependencies, guys. Okay, so life cycle of pod and service are not connected, which means if a pod goes down, the service may not necessarily go down. It is independent of each other, is really what it means. Most of the time, the service doesn't go down unless we manually turn off the node and things like that. It doesn't really have to go down, but a pod can go down because the application is running inside it. If there is an unknown exception or some kind of serious problem in the application, then the entire process of the container may fail, and that is where the service will continue to be alive, whereas the pod may go down. That is really what we mean by it is not connected, guys. Okay, pods can go down, as simple as that. So what do we do? That's where the service comes into the picture and takes care of it. Generally, the service is exposed to the outside world through the browser, and we give some kind of a IP address, node IP port, and things like that. But in most of the times, whenever we have applications, there is also a database for that. The database is also run in a different service, and that is the database is generally plugged into a container and a pod and exposed as part of a service. But generally, a good idea is not to expose the database IP address. It is also not a good idea to expose the IP address of the application. You generally give more meaningful app names rather than the exposing the IP address. Even a database server, it is not a good idea to expose it to the external world, because anybody can start accessing your data and they may be looking at the data in your database, guys. Okay, so ideally what will happen is you can specify the type of service on creation, internal service or external service. External service is generally for applications for us to give external IP address or maybe external URL and things like that. Internal is something like internal IP, internal service, which is within the network and things like that. You want to connect, and knowing the IP address or the location of the database within our company, business, enterprise, or within our networks is okay, but not outside our networks. So that is what it is. Internal service is the default type. By default, it is internal, and we'll try to understand what that means, guys. Okay. So more precisely, what happens is most of the times we do not expose the IP address of the applications. We bring up the we tend to give a meaningful URL, something like a myapp.com, and the people around the internet will generally access our URLs to access the IP address. Is a good practice and a best practice, guys. Okay. And the ingress is nothing but it kind of acts as a route wrapper to the service. In other words, it routes all the requests to the service. So it is like another port, which is, instead of exposing the port of the service, we are exposing this port that routes all the requests to the service. Can be thought of as a definition of ingress, guys. Okay. And so if you look at this one, we have MyApp and a database. MyApp is your web application or maybe a Windows application. Database could be a MongoDB, a relational database like an Oracle or an SQL Server, and things like that. Database URL usually is in the built application. In other words, anything related to database, which is generally the IP address, the URL, the username, the passwords, and things like that, if we code them into our source code, then any small change, pardon me, in the IP address, username, password, or any other configurational related settings of a database may force us to rebuild the app, may force us to push it to the repository, then create the container, then turn on the pod and deploy the pod. Again, all these steps needs to be done manually, which is generally time consuming. So in other words, generally, we do not expose the configuration information of the database in the source code. We do not hard code them. We try to put it into a configuration file. That is nothing but the config map. It is for non-confidential data only. So again, it is more precisely, any configuration information is generally recommended to be put in the config map for the application, so that changes in these things, because the servers, the IP addresses may change and things like that. These things can be independent of the source code, is what the objective is, guys. We don't have to, again, others, there will be less impacts on the upstream and the downstream applications who are connected to our apps and databases. So we provide another file, config map, where we store the username and the password. Then we have something called a secret file. Secret file is where all the secret information, such as more precisely username and passwords, are saved. And even in the config map, we try to refer to the username and password in the secret file. So very few people will be given access to the secrets. Administrators are generally given their access. Use it as environment variables or as a properties files. In other words, we can also use the secret file as a for plugging in any environment variables, which may be used for cross container or pod communication, and many other things, guys. Okay, reference secret in deployment. So in other words, more precisely, the config maps will refer to the secret file for any of the sensitive or the confidential information, such as the usernames and the passwords, guys. Okay. So again, if you have a look here, we have a node with maybe a web application, maybe a DB application. Both of them are in separate containers and pods. They're being exposed by separate services. Generally, for an app, we try to save the data in a database. The database data could be saved in its own data, but the problem is if it is sitting in a single container in a server, and if the server goes down, then what can happen is the data is unavailable. And if you bring up the server again, it is possible the data is getting corrupted and things like that because of the unnecessary shutdowns and things like that. So when most of the times the data in the database is mounted or saved to a local repository or a remote repository separately, so that even if the container goes down, the database, we do not lose our data. It could be stored on local or remote machines. Kubernetes doesn't manage data persistence. Data persistence is really something which needs to be managed by the application architect or the technical architect and the database team. It is not what Kubernetes does for you, although Kubernetes has some support for stateful applications. Stateful applications means generally the applications which require you to store the data. Kubernetes is helping us manage, is used for managing the containers. Inside the containers, how you store the data, where you store the data, and it needs to be handled at an application level, not at a Kubernetes level. So generally, we don't manage the data of an application directly. You don't persist it directly using Kubernetes. So it has different tool is what you can think of here. So again, volume can be mounted onto local or the remote volume. And generally, we give different services, an external service, internal service, a valid URL is what we use. So at any point of time, if an application goes down, what can we do? We can bring up. That is where the team comes into the picture. And what do? That is, team comes into the picture and they bring up another node or maybe another service which is related to your application service. That's where the distributed systems also come into the picture. The world of big data is nothing but distributed computing. And these are the principles which are borrowed from the distributed computing. They come into the picture. And what do? When an application service goes down, what you can do is you can automatically have it come up from another one, have it serve the request from another node or a server. How do you do that? You replicate it. In other words, you do not deploy your application in one server, deploy it in multiple servers so that the load or the request can be balanced. Not only that can be balanced, but if one of the server goes down, we can still have a request served from another replica of it, is what it really means, guys. Okay. So permanent IP address, the service allows us to give a permanent IP address. It will also take care of the load balancing part of it, which means if one of the app or the containers or maybe the pod goes down, it will reroute it to another one. The service will have knowledge based on the hosts and things like that, and it will route the request to the another worker or the server. We can also say it defines the blueprint for the pods, specifies how many replicas you want to have. So in other words, these things are generally specified in configuration files and not in the code or anything. So it gives you it is kind of telling you the architecture of the pod. This pod will be here, available here, will be available here, maybe in 2, maybe in 3 replicas or more based on the requirement, guys. Okay. Then we have the deployment. It is a blueprint for my app pods. So deployment can be thought of as another wrapper, another layer on top of a pod. Generally, what we do is we don't directly work with pods, we work with deployments, is what it is. We create the deployments and abstraction of pods. So this is an abstraction of pod means pod is doing a lot of complex things with container, but it is hiding all those things. So it is referred as an abstraction. Similarly, in order to work with pod, they created another layer which is referred as deployment, which is nothing but an abstraction of pod. What it does with pod is hidden from us, so it is referred as an abstraction of pod is what we can think. So in other words, we create and deal with the deployments rather than creating and dealing with the pods or the containers is what it is. So what we have here is if we have an my app and if we have multiple instances of it running in multiple nodes, then if one of the server goes down, service will automatically reroute it and have the service or have the request served by another instance of the app, guys. Okay. But most of the times when for databases, it's not handled like that. It is generally not a good idea to maintain multiple instances of DB directly like that. You generally mount your data separate, have your data mounted separately, and you can try to maintain one or multiple on top of it, guys. Okay. But most of the times, if Kubernetes or if you're using Kubernetes to save the data into the database and we are maintaining multiple pods or containers or maybe deployments for Kubernetes, then what will happen is a lot of state management needs to take place. In other words, the servers need to be synced up with the right amount of data at the right amount of the time about the reads and the writes and the things like that, which are really the characteristic of an application architecture. An application should be able to take care of all these things at an application level. And DB can be replicated via deployment. In other words, it's generally not recommended to maintain multiple replicas of the data when you have the data getting saved directly into the database, guys. Okay. So we should try to avoid the data inconsistencies by using separate mounts on external or local hard drives is really what it means. These are examples of some stateful apps. Stateful apps is where our app is storing the data into the database. The database is in the container is in the pod is in the deployment, and that is being managed directly by the Kubernetes. How you save into any of these things is directly managed, which ideally what I'm suggesting is generally taken at an application architecture level. We don't have to manually do that, guys, because the data is being manually saved and things like that. That is referred as a stateful. architecture. Stateless is where generally we can do stateless and stateful. Stateless is generally preferred in a best practice, again, for the same reason that the application architect will generally be responsible for taking care of the reads and the writes and other kinds of things at a application level rather than at a network level is what you can think of, guys. Okay, so stateless is we are doing something in our application, but we are not saving the data in a database directly. We are letting the application save it. The application saves it, and we also do not directly, or we do not have any intermediate steps in saving the data back to the database. There will be a few business rules, validation rules, which are generally taken care at a UI level. We don't have to worry about them. But if you're, to be more precise, what I'm trying to convey is when you're not saving the data manually as part of the Kubernetes, you're not helping your application save the data manually into the database, then that is what is stateless. Stateful is where we are using Kubernetes to save the data into this server, this database, that database, and many other things manually. If you were to, that is referred as a stateful. It could also be saving the data into a single database only, is what is stateful, guys. Okay. Rahul, Shrishil, doing okay, buddy? Can you give me a quick yes? Okay. See where we are. Make a little progress. So deploying stateful is not easy. It is not recommended. You have to really work with the application architect and try to understand what his requirements are, what their needs are. Ideally, at an architectural level, unless there is a real need, they will not come to you for a stateful deployment scenario, guys. Okay, they will generally take care of that. Databases are often hosted outside of Kubernetes cluster. In other words, database, we generally don't put it inside our Kubernetes cluster, or at least the data can be put outside, is what it really means, guys. Okay, so slightly heavy on theory, just bear with me. And at any point of time, if one node goes down with the application and the database, we do have the second one node with the database and the application up and running and things like that, guys. Okay. Okay, these are the main components of the Kubernetes. Pod can be at a high level set as an abstraction of containers, which means it is hiding a lot of complex communication with the containers from us. It changed, and it changed its Okay, sorry about that, guys. Let me see. Rahul, can you make me the host, please? Oh, sorry, I'm already the host. Okay, sorry, guys. There was a slight network issue. I couldn't join into the network, and I'm using an alternative one to join here. So sorry about that. My apologies again. So let me share my screen. Okay, here we go. Let's see. I'm making sure Rahul, Himera, are you there? Can you give me a quick yes, please? Thank you, Rahul. Sorry about that. Okay, so some of the main components at a slightly high level, we can think of pod as an abstraction of container. As I said, abstraction means it hides all the complexities of container and acts as a layer around the container. Service is facilitating the communication between the service, the pod, and the container. If you recall, the container itself has an IP address, which the pod gets, but we, instead of communicating with the pod, we communicate with the service. That is what it is. Service also provides a few other things which we will see. Ingress is again acting as a router. It is routing the traffic to the service, and that is as simple as that, guys. Okay, moving a little ahead, config map. This is where config map and secret is where all the configurations are shown. Anything which is very highly confidential can be saved into a secret config file. Config map is only any other kind of configurations can be saved into the config map. Volume, again, we can mount the volumes for persisting the data and keep the data separate so that just in case the containers or the pods go down, the volume is not lost, and things like that, guys. Okay. Deployment, generally a stateless deployment. Deployment is again another layer around a pod is what we can say. We generally work with it at a deployment level rather than at a pod level. At a conceptual level, we're interacting at a pod, but the deployment is what we generally create and work with, guys. Stateful is where we have the data also being managed at a Kubernetes level, which is better done at an application architecture level. From an application service standpoint, it is generally a good idea to maintain multiple applications for multiple replicas of the application, so that and load balance them using the services, so that if one of the containers, pods, or the servers go down, we have another one picking up the request and serving it, guys. Okay, so we have to create the resources and configure the K8s cluster, and Kubernetes configurations is some of the things that we need to have a rough idea. So here is the API server UI. This is how the UI looks like. API server is what it is behind the scenes interacting. It is one of the main components of the control plane, which is accepting all the requests from the external and the internal world, and serves the requests for the workers and other kinds of metadata management, guys. Okay, we have UI, we have API and CLI. kubectl is the command line interface for the Kubernetes, and that is the most powerful interface for interacting with the Kubernetes cluster, guys. Okay, so deployment, a template for creating pods. This is how the configuration file of the Kubernetes looks like. The kind is where we specify whether it's a deployment. A deployment can be thought of as a pod. It's a wrapper around the pod. It can also be a service or other components, which we'll try to get a quick feel of it. Under the kind, we have metadata. Under the metadata, we have spec. This is where we maintain the low-level design details of the infrastructure. So this template acts as a high-level architectural document. We maintain multiple templates like that based on for an application, or maybe at a component or at a service level also, we could maintain these configuration files, guys. Okay, we'll discuss in detail. Generally, the exchange between the API server and the interfaces to it happens either using YAML or JSON. We have briefly discussed about the YAML. YAML is also nothing but a touch of JSON, but much more better than a much more evolved JSON is what we can think of, guys. Okay, so here it is. We have, if you go a little bit deep into the YAML file, the replicas is 2 means for an application called my app, we are maintaining 2 replicas. The replicas is generally maintained in multiple servers. It is automatically handled. If we specify 2 replicas, we are telling Kubernetes, hey, here is an application called my app, and we would like 2 instances of this my app to be running, and that's where the service is coming, and they will always make sure the replicas are up by working with the Kubernetes internally and so on. So selector match labels app is my app means this is the application, this is our application where we want 2 replicas or multiple replicas to be run. Then we have metadata and spec. We'll talk about those things in a moment. Let's go a little bit. So here is the containers. So this is the containers information. It is as part of the image is my image. We've seen how to build an image, and the name of the application which is running inside the container is my app, and the image is nothing but it is the blueprint for the container is what you can think, guys. Okay, or in other words, container is a runtime instance of an image is what we can think of. Then there is environment. Environment is just in case if we are really involved in maintaining cross communication between the container pods and services where they're communicating, and that's where we could use some environment variables. Ideally, we don't have to necessarily define these things. They are nothing but they are also thought at a level of an application architecture level. A technical architect would ideally design these environment variables. Also here and there, we may want to add some environment variables from an infrastructure and point of view, guys. Okay, they're nothing but the key values. This is nothing but a YAML. Key value is nothing but a dictionary, if you recall. We have discussed earlier in the earlier days, guys. Okay, so controller manager checks desired state equals to actual state. That could be whether it's a container, service, or server. Desired state is we want this container or maybe the server to be up and running always. Just in case for some reason the control plane or the master detects that the container or maybe the service is not running, that is not a desired state. The actual state is maybe it is down. So what do? You need to match this. What do we do? That's where the master, the control plane or the Kubernetes is coming into the picture. It is automatically going to come up and try to bring up a container on another server or on another server or in the same server also it could be. That is what we mean by is equal to should. Is we always want our containers and servers and services to be up and running, guys. Okay. And moving a little ahead, it's generally referred as a declarative syntax. That is nothing but the YAML. So 3 parts of configuration file. So here are some examples of configuration engines. Is a kind of a web server, and there are 3 parts in this one. The first part is going to be the metadata. Metadata is where we are telling whether it is a deployment object or a component or a service component or an object. Again, deployment component. The kind is deployment means it is a deployment component inside which a pod runs, and inside a pod a container runs is what is. Service means a service can refer to a group of deployments or maybe a group of pods or containers is also what it can be. That is what is referred as a metadata, guys. Okay, it is something which is used by the master and the more precisely by the master to keep track of all the workers and other things about it. Spec is where we are saying, hey, how many replicas do we need? Again, for a deployment or a service, as simple as that. And there are lots of tens and tens of attributes, but we'll see a look at a few of them. This is also part of the specification. The kind is telling whether it's a deployment or a service. API version, that is, we need to use it as per the, for deployment, that is the syntax, and for the service, attributes of spec are specific to the kind. Based on a deployment, you have the API version, which is being used. So there are 3 parts of the a YAML file. The metadata and the specification is what we looked at briefly. Status is something which is automatically generated and added by Kubernetes. Whether a pod or a spec service, it could be running. If it is running, then the status is running. If for some reason it is not present, it is terminated, or maybe it is in some other state, then the status would change. That is something dynamic. That is the 3rd part of the spec file. And constantly Kubernetes is constantly checking if the status is what is desired. Is it up and running or not? Sometimes you may want to manually force some of the services not to be not running. In such case, it is running, then that is not a desired state. It will actually terminate it. That also can be done as part of the Kubernetes administration, guys. Okay. So desired is not equal to accurate, then Kubernetes comes into the picture and will automatically take care of it. We will not have to worry about the status. That is the third part of the YAML file, guys. Okay. K8s update state continuously. So based on whether the services, so all that is handled by the master. Master looks at the template, these templates, and tries to take care of all these things within the workers is what it really. And replica is one, again, is ideally saying that, hey, this kind of a component, we only want only one replica of it to be running is what it is. Or I think what we are doing is the actual is replicas is 2, whereas our desired state, there is only one replica running. So the Kubernetes comes into the picture and it will automatically spawn and another server or a container with the replica running and make sure it is running and try to bring it up to the desired state is what it is really about, guys. Okay. There are a lot of other attributes here. Some of them are pretty self-explanatory, but these are some of the important things. So how do you get the status data? That is where the master comes into the picture. Master has something called an etcd database. It's a key value store, a NoSQL key value store where all the metadata is being maintained. The master is the control plane is constantly monitoring all the workers and trying to store their status periodically. And all the status and that kind of data is stored in this etcd database is what it is. Going before we go into the configuration files and things like that, let me come back here. Rahul, would you like to get into action?
Yes.
Okay. Could you please open up the instances, please? Let's see, where am I? Sphere. YAML configuration files. For that one. Okay, let's see where you are. Instances, let's go ahead and launch 3 new instances. We'll call one of them as master 1, another one as worker 1 and worker 2. Start with Ubuntu. Names and tags. Starting with master. They're changing almost lots of changes happening here. Look for Ubuntu image. We'll start with Ubuntu. History volume. Micro is good. Key pair, you can generate a new key pair. And launch 3 of them, please.
Yeah.
This is just a K8 something. I've already given that name. K8 key, okay. And allow SSH, allow HTTP from the internet. Allow HTTP also from the internet, just so that we save one step. For now.
We need 3 instances. Right?
Yeah. This is the first time I'm seeing this look and feel also. I think the rest of them can be going to the advanced details. Let's just see if there's anything. PB4 instance auto. No, none of these things we need at this stage. I think we should be good with these things. These are not needed at this stage. 3 instances, that is what I need. And
and storage, this root volume.
Good. That should be
8
good.
GB is enough.
Yeah, or maybe just increase it a little bit if you could. Maybe it's allowing you to type maybe 12 GB or something like that. Yeah, that's good. You can launch it. Give it a moment and you can go back to the instances. Make sure they're in the running stage. Oh, sorry. Is it the one that you just created? Pending,
Yes.
okay. How come there are, oh, achha, all the three got same name. Sorry, I was.
Yes.
Maybe just
So they are.
we got the space. Just one of them is master one, two others are worker one and worker two.
Yeah.
And also take some time. Can you try to bring up your terminal? Let's see, connect. I think we'll need to, I would say, bring up three terminals and try to connect to three of them. Put two of them on the right hand side, one of them on the left hand side, just for kind of discipline. Put the master on the left hand side and the workers on the right hand side. We'll have a little bit more work with the master.
Yeah.
And this is the master.
Yeah, this is the master.
Okay. You may want to log into the two workers also on a couple of nodes.
Yeah, I have logged into those two.
Okay, good. Then let's say come back here and check something here. Okay. Instances. Okay, here is the first one. First up, I'm going to paste into the chat window. try to run this on the 3 of the nodes. You can put two of them on the right hand side so that we can look at the process. Here is the second step also. I've sent you the curl command.
Should I run this on the master node?
Yeah, you need to run this on 3 of them.
Okay.
On this one also.
And this one also on all 3 nodes.
Yeah. Yes, please. Have you run the curl on the second one also?
Yes, I have run.
Okay. So this is going to be installing Docker. I'm sorry, that is going to be downloading the Docker. And let's say here is the next 2 of them. Here are the next 2 of them. Run these tools on all the 3 of them. Just doing it step by step to keep it easy. And what is the last command? Okay. Install Docker C. Okay. Here is the next one after that.
This command also on all 3 nodes.
Yes.
Right?
Yeah. And GPG. Here is the next one. These 3 need to be run at one time. Same.
So this one also on all 3 nodes. Right?
Yeah.
the output it is showing, is it correct or there is some mistake?
Looks good. Looks good. Next, we'll install 3 tools. Here is the next 2 of them: kubectl, kubeadium, and kubelet. So you have run the sudo apt-get kubelet, kubeadium, and ctl. Is that the last command?
Yes, yes.
Okay. So let's see. The next one, okay, we need to establish the bridging. So let's see this. I'm giving you a step by step because I faced some errors and I just want to. It'll become easy if you run step by step. The net.bridge, this will establish the bridging. Okay, no problem so far. Okay. Okay, try to run this only in the master. We're going to initialize the administration here. I paste this one. The kubeadium in it needs to be just run in the master. So the number of available CPUs is 1 less than I'm required to. System RAM is less than. And we're doing kubeadium in it. Can you copy paste that error into this one, please, into the chat window, please? Yeah. Okay, 1 moment.
It is maybe saying that we need more CPU. We have taken only one vCPU.
Let me just
And RAM is also.
make sure about that, Rahul. Give me one moment. So this is 100 megs. These things were running, but give me one moment. Okay, let me paste something here. Can you try running all these things at one time?
On all three nodes.
No, only on the master. Say yes. And bring up the last command that you ran. What is the last command? Reset. Okay. Sending the next one. Try to initialize the admin. Send you the next one, Rahul.
Yes.
CPU. Okay. Can you go back to the instances and see if it is allowing you to add a CPU?
Yeah, we can change their instance type.
Okay. So we're using micro. You want to change the, you just want to change the instance type, huh?
Yes, yes. We can take to medium.
Yeah, if the micro medium is on, I think we will generally, but I'm just.
Should I take this medium?
Please do. Take the medium, please.
To medium is
Choose the Ubuntu, please.
T2 medium is 2 vCPU and 4 GB RAM. So maybe it will work.
Yeah. need to relog in, I think, Rahul.
Yeah, it is initializing.
Okay. You can take a short 5-minute break, Rahul.
Yeah.
Back, Rahul.
Yes.
You can share your screen.
Yes. Yeah, I have connected to all three servers.
Okay, great. So I guess I think these are almost like new instances, right, Rahul?
No, with the command which we have run, maybe they are also there.
I think just type in Docker. Good, Docker is still there. Just type in kubectl. That's it. Okay, so kubectl, let's say it's not installed. Type in kubead. So there you go.
Yeah, it's
Okay, so we still have kubectl, so that means that command executed properly. Let me bring back the chat window. Let's see where we were. And I think there was one command I asked you to just run. 1 second. I think the last one is sudo kubeadium init pod network cider. Try to run that one more time.
networks header. Okay.
Can you also check, just type in kubelet and kubeadium also? Just make sure the agents are there. Shall I start with kubelet? Permission denied. You have run the sudo kube. I'm sorry. What was that command? Sudo. Yeah, we have done the sudo. Failed to construct the kubelet dependency. Kubelet. Docker. Can you just type in which kubelet? Where is kubelet? Anything is fine. So when kubelet, okay, that looks good, but it says failed to construct the kubelet dependency. Okay, that is strange. Can you list /etc/docker? You have key and daemon, okay. Can you do a sudo kubeadium reset? Kubeadium, which is one word. Reset. Yes. Does not play. Let's see, what is the where did you run that? Can you just go to the command where you ran that? No. Scroll up, please. I won't see the first message it gave out. So here's where you said kubeadium reset, and let's say changes to this host or kubeadium join reverted. Okay, but not zooming. Okay, scroll down, please, and reset is done. Do a sudo kubeadium init. Sudo. Yes. This should bring up the master process up. Doesn't really take up that long. Okay. You can join any number of worker nodes. So copy that last two, from there, copy that whole thing, put it in chat window, just so that we have a reference of this. Copy this, put it in chat window. As simple as that. Later we will use this one, but let's say we have a few more steps before we can join that one. And let's see. Need to set up the cube configuration file. Before that, we need to apply the network plugin. Okay, can you run this one? Only on the master, please.
Maybe we need to open this port also.
The connection to servers. Yeah. Can you go back to the instances and do that, please? This was the right host. Can you copy that error message, please, into the chat window? I tested this on t3.micro a few days back. Everything worked.
Okay.
So it looks like some changes are coming up here. Did you specify the port? And give me one moment. I'm going to give you a few commands. Try running this one. First one. I think I missed this step. Sorry about that. Second one. Here's the third one. Please run these three on the master only. Not on the Flanner network plugin. So created, okay. And I think now we are good to go. So let's say try kubectl get nodes. Here we go. Okay. That should give us all the nodes which are up and running, which we don't have. So we have control plane of the master. The control plane of the master is the only process which is running, which is like the master is up and running. Okay, as simple as that. And now we have to get the workers running. For that, what we'll do before we do that, go ahead and let's watch this one. Okay, here's the next one. Say watch it. So there is ready. Now we'll go back to the worker and we will run some of the commands that we have run earlier, starting from the first one. So let me see if I can copy them here. Right from here. So we did a curl, then install the Docker. I think you can run all these things at one time up to here. I'll copy this one. Paste it here. Okay. Run all these things at one time in worker 1 and worker 2. What's that? Looks like something is picking up there. After this, just scroll up a little bit, please. Looks like some error, some message came up. Further up. Here. Command URL not found.
Okay. The URL instead of curl, maybe there is URL.
Scroll up, please. Oh, you typed in URL instead of CURL. Okay. Just change that and try to run it again. Oh, I see. My bad. I gave you to you as URL. Okay, I didn't paste it correctly. Just put a C in front of that and try to run it once it is up. You can stop that. Put a C and paste it. Yeah. Now copy the whole thing. File available. Manifest Cube API already exists. Oh, that's because I think to see the stack trace of this file available, Kubernetes controller manager.
Yeah, maybe they are already exist. They are, that's why they are showing it. We have already run this one.
Yeah. This is city. If you know what you're doing, you can make a check compatible. Okay, that's okay. We'll take a chance here, and let's see, come down here. So back to the chat window. Just verify Docker kubectl kubectl kubeadm. Docker is good. Kubectl kube. List of options. Okay. Then kubeadm. Then type in kubelet. Good. Kubelet. Okay, now it's time to just verify on the other one also, just be on the safe side. Get response. Okay. So now I think it's time to join. So join the master. So before we do that, let me see, have you done the IP tables things? IP table is done. Cube, you have done. Cube ADM minute. Okay, looks good. And let's see what was next step. I think now what you can do is you can copy that cube ADM join that you pasted earlier in the chat window.
Yes.
Copy that whole thing, paste it in the two workers.
We need to do into
Yeah, here, sudo cube ADM. Where did you join? You should have. Did it join or is it again? Do a clear and run it again. There's too much.
again.
Cube. Sudo cube ADM. Okay. ETCCA already exists. CA.crd already exists. See the. You can make a check with non-fatal with ignore pre-flight errors. We could. Some fat errors occur. I've never used that switch. What I'm thinking is maybe if we can just remove the kubelet.conf and ca.cert and try to run it again, just to be on safe side rather than ignoring. Remove those two files, kubelet.conf. We need to do a sudo, I think. The ca.cert. Okay, try joining. And go back to the blue window. It'll, because we're watching it. Also, there was an indication. Okay, nothing coming up here. Okay, go back. You can put them parallelly. There you go. That should be good. Okay. And it's coming up what we are doing, Rahul, guys, is we are doing all these steps manually. And just to get an understanding of the masters and the workers and things like that, how to join the workers and things like that. Tomorrow, if we need to go ahead and commission a worker or decommission a worker also, these steps will give us an idea. But ideally, we can also use the EKS. Master setup is generally much more complex. And there are a lot of other things that we have to do. That is where we are headed to. If we have a basic idea of some of the steps, then we'll slowly go to EKS where the master is automatically taken. We just specify the number of workers and we are good to go and we are ready to run and things like that. Catching the point, Rahul?
Yes.
Let's give a minute here. while we are waiting, repeat the same step on the other worker also, Rahul.
Yes.
Okay, delete the files. We're joining here. Oh, okay. Because we have enabled that one, right? Can you stop one of the processes, Rahul? One of the workers, just do a Control C. And there is a command we have given echo net.bridge bridge.nf call IP tables. Copy that one. Run it here. Oh, go back to the previous one. Looks like it has it completed or is it still running? Previous window, the black one.
It is still running.
Okay. Okay. Come back to this one. Then just do an echo, and let's check to see the bridge what it displays, because we have removed the
Net bridge.
it is the last second or the last third one in the one.
Yes.
So we get IP tables equal to 1. Okay. It's taking a little too long than I expected. I don't remember taking it that much time. So do the next step. So sudo sysctl -p sysctl, the next command.
Yeah. Sysctl.
Is okay. And let's say we have already run the Kubedium init pod network, right?
Yes.
You run it one more time, please. Kube scheduler, kube controller already exists, which means there is a Kubedium. One moment, I'm looking. Command and worker 2. I think it's because we ran it 2 times. I'm thinking we're running into some of these problems. So just give me one moment.
Yes.
So there's
Yeah. It's showing some output.
Is this the one that you just changed the port?
Yeah, I have added this all inbound, all traffic between all these three nodes.
Oh, okay.
That,
Okay, could you please do that for the other one also?
yeah, they are in the same security group, so it get applied to all the nodes.
Oh, okay, then go ahead and join it.
Okay.
Okay, making progress there. Oh,
Saying that the connection.
is it happening on both of them?
Here it is showing something. Waiting for the kubelet to perform TLS.
Can
Yeah,
you
it is showing same here also.
copy that error message, please, in the meantime?
Yeah.
Just to be on the safe side, do me one more thing, Rahul. Go ahead and spawn or bring up another worker instance. Call it worker 3 or something like that, just for the sake of discipline, so that we have a fresh install.
Okay.
Medium.
Sir, can we take a short break here?
Yeah, please. Let me know if you're back, Rahul.
Yeah, yes, sir.
Okay. Could you also upload that key file to our G drive, Rahul, just in case I want to get into it?
Okay, sir. Sir, maybe I don't have this permission to upload the file here.
Oh, okay. Can you share it in the chat window? Try.
That key file in chat window. Okay.
Let's just copy paste the content. Pardon me, sorry about that. Are you able to upload it, or if you're not getting it, that's okay. Proceed. Oh, it's a prayer. You can, I think it may not even allow you to put it in the chat.
Yes, it is not allowing me to paste.
Never mind, don't worry about that. Rahul, go back to the terminal, the new worker terminal. See, let's try
Okay,
to
okay, a new one. No? Right.
let's try to execute. I'll give you this steps one more time. Let's try to carefully execute them and see if we can get this up. Interesting. Okay. Well, okay. So here are the first 4 things. We'll run them step by step, just to make sure. Try running up to here. Make sure there are no errors. Then after that, here is the next one I want you to run. Okay. Here is the next one. I've done that. Okay. Here is the next one. Just running these things step by step. And this is T2.medium, right, Rahul?
Yes, it is T2 medium.
Okay. Here is the next one. Okay. Try joining it.
So can you send that?
It's there in the chat. Okay. No errors so far. Oh, shoot.
It is showing same error.
It's 102. Is this the same error that you pasted earlier?
Yes, it is same.
Try this one. You can try stopping that and run these things. And did it ask you to press say and yes after you did a reset? Just scroll up a little bit. You did press say yes, right?
Yes.
Okay, that's all I want to mention. Then let's say, and now try to join it. Oh, there you go. So if you notice on the left-hand side in the blue window,
Yeah, it is. Yes.
certificate signing in, kubelet was informed. So go back to the blue window. So it looks like it's still getting ready. One of the master is ready. If you give it a few seconds, it should say ready. So which means it is listening to the worker node. If we follow a similar process, we can bring up tens and tens of such nodes. I think 1000 nodes is what is the official limit for per master. And we should be able to run as many nodes. The next thing is we need to check some of the, do a control C here. For now, I'll just run one node here, one worker.
Here on the master.
On the master, yes. And let's say kubectl get nodes. So there are two of them. Just for the sake of discipline, go ahead and run these steps on another worker, Rahul. Just so that one looks too small, at least two if we have, it looks like it's a multi-node. No, I think you need to join it. Before you join it, just run the previous commands that we have run. And now join it. You can do, okay, you can do get nodes on the blue one. We should see an additional one, as simple as that. So even that is ready. So we can keep on adding as many nodes. Ideally, we could run this on multiple times. We can try to integrate Ansible and try to run all this stuff at one shot. We should be able to find some scripts. We don't need to be able to write that manually. But that is how we're running the master and the worker. Let me see, come back here. Just say kubectl get nodes you already said. Go back to the master. Get nodes instead of nodes, say pods. Okay, enter. So what is a pod? Pod is ideally, it is having container. Right now, we don't have any apps and things like that running. What my plan is, we'll get a quick feel of how to run a pod and container. I'm working on some samples for you guys so that it becomes easier for you to understand. Then we'll try to look at a much more bigger cluster and things like that using EKS and so on. Okay, Rahul?
Yes, yes.
Okay. How about Humera, Moin, let's say, who else is there? Aniket, Kajal? Are you all with me, guys? Can you give me a quick yes, please? Okay. Okay. So here is my plan, Rahul. For today, I want to stop here. We'll continue from here tomorrow because I need to get onto a quick call. And we will look at a few examples tomorrow and try to get a feel of that, Rahul. Okay?
Okay, okay.
For today, allow me to sign off here. You guys take care, stay safe, and keep learning, guys. Okay?
Okay, okay. Thank you, sir.
Thank you, Rahul. Bye now. Thank you, Nitish.